Hi everyone, welcome back to another video. Well, it's seemed like ages since we've seen the sun. There's been so much rain and wind going on for days and days and days. And I'm not really sure if there's going to be a chance tonight for a bit of clear sky, possibly a couple of hours or something, not sure. But I thought it was about time that the Meade 10-inch had a bit of a turn in the observatory. So it's sitting up here on a CEM 120. Normally in other videos it's been sitting on the CEM 60, but I thought it was time for it to have a go in the observatory. And also on the back here I've got the ASI 1600 this time, the ASI 2600 Pro. Normally this has been paired with the ASI 1600 and the 1.25 inch 7nm optolong filters, but this time I thought I'd let it have a go with the 2600 Pro and the Antlia 3nm filters. I quite like having a long focal length, not just for planets and the moon, etc., but also it's quite nice to sometimes just home in on an area of a nebula, like maybe the center of the Lagoon Nebula, etc. But I wanted to have another go at the Pillars of Creation in M16, or the Eagle Nebula, and see if I can improve on my last picture of the Pillars of Creation. I'll just run you through the rig that's on here exactly, because I've got another piece of new kit in here. So of course the Meade 10-inch, which normally has a native focal length of 2500 millimeters, and on the back here is the Asato 2-inch robotic focuser. Now I've got the Lepus 0.62 telecompressor, they call it, or focal reducer, from Optec. The other thing that I've added in here is I've got the ZWO OAG, and this is the large one with the much bigger mirror, and I'm hoping that will help me find some more stars compared to the smaller one that I have been using on here with this telescope. And of course the 2-inch filter wheel with the Antlia 3nm filters and the ASI 2600. So that's a quick run through of the equipment I'll be using. Hopefully tonight, if I can get a bit of time on the Pillars of Creation, I'll probably try and, if we get any more clear nights in the future, add a bit more time to it, because I want to collect a few more hours than I did last time, see if I can improve on my image from, I think it was last year, and see how the big telescope goes with the 2600. So yeah, fingers crossed. Okay, so we're in Pixinsight, and I'll show you what I got with my 9.5 hours of integration. This is the HA. Traditionally has most of the detail that we want to bring out in the image, and also use often as the luminance. Now, it had some nice detail in these sort of dark bits of nebulosity that were floating around the bright background, but I was a little disappointed at the amount of data that was coming out, or detail should I say, that was coming out in this tall pillar. It was kind of merging in with the bright background. So that was fine. That was what the HA looked like. Now the O3, that sort of mostly captures this brighter area that we often see in the SHO images of the Eagle Nebula, or the heart at least of it, where the pillars of creation are. You often get that blue-green background. And there's not a lot going on over here. It's all a bit bland. And over here we are picking up some of this sort of darker, interesting little bits of nebulosity, but I really was collecting the O3 just to get this bright sort of background here to use for the color. So the O3 I captured the least of. And then when I was looking at the S2 as I was going along, I noticed that most of the detail in the pillars was in the S2, and also they were a lot more defined from the background because the background wasn't quite so bright. And so for this reason, I actually spent most of my time on the S2 so I could get all this nice detail here, because I knew that in these other areas here, and also these little sort of dark areas that are floating around which are not so obvious in the S2, I had those in the HA. And then it was a matter of working out what to use for my luminance to get the most detail, and I'll talk about that later. So obviously also when you're looking at these images, you can see that there is a vast difference in the appearance of the stars between the S2, the HA and the O3, and I didn't really want to combine them as is, because I would end up with way too much of a contribution from the S2 compared to the HA. So what I wanted to do was sort of shrink the stars down of the S2 and the O3 to match the HA. And what I ended up doing was using one of the tools of this group of tools that Bill Blanchard made available to us all kindly. He's come up with these fantastic star reduction tools, and there's different methods here. I won't go into how it's done or what the different methods do. You can have a look at that if you go to, I'll put a link in the description below, but Luke on his channel, Luca Matico, he sort of presented them on behalf of Bill, and then showed a video of Bill explaining exactly how they're all used. So you can have a look at that video if you want to see how to use them, but they're fantastic tools for reducing the stars in a nice way that's not sort of making them all dull. It still retains their lightness, brightness, their shape, and you can, when you combine them, you haven't lost the color through them being all bland. So the method I was using was method 3, and on here there are a few little things you can change. One of them is the number of iterations between 1 and 3. I usually leave it on 1, and then I usually change the strength to either moderate or soft. I think I use moderate on these two and soft on O3. So what I did was with the, let's go to the O3 first. And if we just step forward, I've applied that star reduction once and then a second time, and you can see now they've shrunk down to something similar to what we're seeing on the HA. And with the S2, I again applied it twice, I think with a moderate strength, as I said, because the stars were so much more bloated. And they shrunk down again, and now I've got something a little better that matches. Then it was a matter of stretching them and combining them into the color image, which looks like this. And interestingly, I didn't really have much in the way of magenta in the stars. It was just this background magenta, which I then dealt with subsequently. Now, I just kept some examples over here of where I've got the S2 and the O3 without the star reduction. And when you combine them, you end up with this. Now, you do end up with more sort of purple looking stars, easily dealt with by either just inverting, applying the SCNR tool to remove the green, because when purple, or magenta should I say, inverts it, you get green. And then you remove that green, and when you invert it back, the magenta's gone. So if I step forward here, as you can see now these stars look all green as it's inverted, and then you apply the green removal, and then you invert them back, and suddenly now you've got nicer star colors. One of the things though I noticed, if I compare these two, and we'll just zoom in a bit, and if I just grab this, sorry, I'll move this over to here, so we got a similar images there. And if you look at these stars, you can see that these are much more controlled. You got this the star there, and then it sort of reasonably quickly tails off into the background color, whereas here we've got this very gray surrounding zone around it because the stars are so bloated. And when it comes to removing the stars with Star Exterminator, now I'm not sure this is going to show up on YouTube, but to me, when I look at this, I can see gray patches left where these stars were. Whereas in this area, if I remove the stars, oh, sorry, I did some magenta removal there too, but let's just remove them now. They just completely disappear, and I'm not really left with those grey patches again like there are over here. So that's, you know, that's quite nice for when you are left with your starless version. You don't have sort of funny grey bits in the background to have to deal with. So yeah, that's how I dealt with those stars, and move on to the combined image and where I went to from there. So as I said, there's the purple background, and we want to get rid of that, and you can do the invert SCNR degreen and invert back again, or you can be lazy and do script utilities, correct magenta stars, which does exactly the same thing, and there it's gone. And then I then removed the stars and ended up with something that looked similar to this, with the stars all gone, and then to work with the colors and, you know, get much more warmth into it, and try and also separate these pillars out from the background. I didn't like the way this sort of fades into the background, because you do tend to lose that detail because of that. So I wanted to separate these out from the background. I used a series of color masks. Now, unfortunately, when I was making this session and saved this whole thing, I ended up removing the color masks. So in this project, I don't have the color masks on here anymore. But so when I sort of step through the changes using curves, etc., you won't see the brown bit here, and I sort of can't show you the color masks, but you'll see the changes that get made using curves. So just stepping through here to bring a bit more warmth into the surrounding parts of the nebula here, while trying to maintain the bluey areas, a bit of yellow through here. And then stepping forward a bit just to sort of highlight this area. You know, there are some harsh differences in the colors here, but that's all dealt with later on. And I'll show you what I did with that. And some more changes just to brighten things up a little bit more. And where have we got to there, just again to get some more warmth in there, and again to separate out these pillars from this background, because I didn't want them lost in the background. And then it was a matter of just applying a bit of convolution just to sort of blur things out a little bit, to try and soften these sudden changes in the colors, because we'll be applying luminance to that to try and bring out all the detail. So the next thing was what to do with the luminance, because as I said, the HA didn't have a great deal of detail here, but had a lot of nice detail here, and the S2 had all the nice detail in the pillars and this area of the nebula. So in the end, what I did was I made starless versions of both the S2 and the HA, and I saved them as TIFFs, and I went into Photoshop. I'll just come over to here. So this is the HA, and as I said, you know, a lot of loss of the detail into the bright background. And this was, I just popped this layer on top, this is the S2, which again loses a lot of that nice sort of those little dark bits of the nebula that were floating around. If I just remove this, you can see them all pop back in here, and also loses all the nice detail of the sort of more cobweb type area. But when you put this in also, it's a lot more noisy. So in the end, it was like, well, what's the best combination? And I decided to use this blend called where I did multiply, and then it was obviously a bit dark, and I just reduced the opacity of the S2 down to 70%. So I had a nice blend of the two of them. I had detail of the pillars, and around here I'd still maintained some of these little dark floating bits of nebula, and I still had this sort of cobwebby look over here. and then just combined that together and took it back into Pixinsight. And if we come into Pixinsight here, so this is where I got to with those combined, and then I wanted to bring out the detail a bit more and a bit more contrast, etc., and sharpen things. So if we just step through this, I did the HDR multi-scale transform tool, and you can see that's increased the the contrast, if you like, and therefore helping bring out some more of that detail. And then the local histogram equalization, again, bringing out more of that detail and contrast. And then I did a bit of a noise exterminator, that's right, because it was starting to get a little bit noisy, but just very subtle, because you could barely see a difference there. And then some curves just to brighten things up a bit more, because I wanted to see more of this variation of the dark and lighter areas. And I think I did it again, one more time here to bring out these, just bring out the detail in these darker areas. And so that's where I got to with the luminance. I'll just put that aside for a minute. And then if we get the image here, the RGB part, and I applied the luminance using the RGB combination tool. And when it did that, it really brought things to life, and it nicely separated out the pillars from the background, so now they were quite clearly seen and not sort of bleeding through into this background area that would look quite bright on the HA and on the O3. And then I want to do a bit more sharpening, so I used the multilinear transform tool, and I had these settings here, about 0.75 and RGB components, and just applied that. And if we just step forward, it sharpened things up a bit, and then a bit of unsharp mask just to sharpen things a little further, like that. And then just worked on a little bit further. There are still some abrupt transitions here in the color that was dealt with in Photoshop, with reducing sort of the color noise in these transitions. So this was sort of similar to where I got to when I was going to put the stars back in. You can see there's still a bit of noise back here, which I did deal with. Now with the stars, so here are my stars, and just move that out of the way. I did apply SNR tool to remove some of the green, and I think I did do the inversion because there was a tiny bit of magenta in there, which I then removed. And then I thought they were still a little bit on the bright side, so I just pulled back on curves really just to reduce them down. Oh no, actually that was an increase in saturation, sorry. If you can see, the color there has just increased in some of these stars, popped up. And then a bit more of a curves transformation just to sort of dull them down a little bit. And then saved that and took that into Photoshop. Now Photoshop is how I've been applying my stars back into my image. I found that using a pixel math method, and I'll show you this, we'll just reset this. If I use a single expression and image footing clone, and this is how I used to do it a while ago, and the stars, okay, and we'll do create new image, and I'll just, now on first look, it doesn't look too bad. But actually when you do zoom in and look at these stars, you can see that they are they're very bright, they're very saturated, you're not seeing much color in them, and they look like big sort of flat pancakes. There's no sort of sense of them being a sphere, they just look like a flat disc. And I had been looking for ways of making my stars look better, and I found the best way to do it, at least at this stage, is doing it through Photoshop and using one of the blend modes. So if we just pop back to Photoshop, and I'll go over to, so here is the starless component that's been processed, and here are my stars that have had a bit of a reduction in the brightness, etc. And I'm just going to copy those, and then I'm going to put a layer, so I'll move this back to the middle, a layer on top, and paste those stars back in. And obviously like this, it's going over the top of everything underneath. So the way that I found was best to combine them was using one of the blending modes, which is screen. And when you get to the screen, you suddenly see you've still got your star colors, and they have that sort of bright center and tailing off to the edges. So they now start to look a bit more like spheres rather than flat, bright, harsh, saturated pancakes. And so that's how I am putting my stars back in with Photoshop and using the screen blending mode. Now, if you use linear dodge through this method, they're a bit harsh, a bit like putting them in with pixel math. What I found is I worked on this image a little bit further. I actually did some cropping, and I sort of worked on this area a bit further. And once I'd put them in screen mode, when I removed them again, if I put them back in with screen mode, they didn't look as good. And in that situation, if you're putting them back for the second time, I found the best way the way they looked similar to the first time using screen mode was to use linear dodge. I hope that's not too confusing, but anyway. So that's a quick run through on how I processed my image of the heart of the Eagle Nebula. As I said, there are some sort of harsh contrasts here in the colors, which I again dealt with in Photoshop with reducing some of the color noise at the boundaries here to try and give a bit more of a blending. I was quite pleased the way it came out. I had the pillars standing out quite nicely from the background and the nice detail of them, and the stars were looking nice and controlled, not too over the top, and certainly was happy with the improvement I made on my image from 2 years. So anyway, I hope you've enjoyed the video. I hope you found something interesting or useful in this. If you have, give us a thumbs up. And if you want to check out any of my other videos, I've got more videos on my channel, some of which go through what I'm doing on processing. And if you haven't subscribed to the channel yet, consider subscribing. That would really help the channel grow. And otherwise, I'll leave you with my final version of the Heart of the Eagle Nebula and the Pillars of Creation. And until next time, I hope you have all clear skies.